So let's start out with a nice, quick, and easy example here. So what I'm going to start out with is let's look at copper, two chloride. So if I was going to find out the chemical formula for copper 2 chloride, what I'd do is I'd start out with the chemical symbol for copper, which is Cu, and then I would figure out the charge of copper, which is 2 positive. How did I figure that out? Well, I looked at the Roman numeral right here, and the Roman numeral helped tell me that it's 2 positive. For chlorine, I know chlorine is 1 negative. I knew that because chlorine has 7 valence electrons. So in my head I thought of chlorine, and I know that chlorine has 1, 2, 3, 4, 5, 6, 7 valence electrons, and it's likely to get one more to get a full orbit. So then what I do is I take the charges and I cross them over to get the formula of CuCl2. So in our next video, now look at how are we going to figure out the chemical formula. Or sorry, how do we figure out the chemical name? So let's say I had Mn. Let's say I had MnO2, or manganese oxide. And so we need to figure out the charge of manganese. So the first thing we need to do is draw our chart. So there's my chart. So now you look at oxygen because you know the charge of oxygen. And so you know there's 2 atoms of oxygen. So I took that number there and I used it right there. And I said there's 2 atoms of oxygen, and I thought in my head, well, what is the oxidization number of oxygen? And the charge of oxygen is -2, because I knew in my head that when I think about it, oxygen has 1, 2, 3, 4, 5, 6 valence electrons, and it's going to likely get 2 more electrons, making it -2. So 2 times -2 equals -4. So because ionic compounds are overall neutral, this side over here needs to be +4. So now I go back to counting atoms, and there's 1 atom of manganese multiplied by some number. What is that some number? Some number is probably 4. So it's, and forgive my spelling, manganese 4 oxide, where the number we find here represents the Roman numeral we will use, and you can even make it nice and make it crossed. When I have this posted on the nice table, and this table helps you kind of summarize what we've just done here. So you can see the steps that we do when we want to find the charge for a variable valence cation. So you see there's the formula copper 2 oxide right there. You can see I draw my T-chart, and then I go through my steps right there. You'll notice the steps are color-coded as well, so when I say charge of the anion here, there's what I'm talking about, and the number of anions, I talk about the overall charge on both sides. And then finally, I kind of made things a little bit backwards here, but still, it's some number times 2 is going to make 2 positive. And what is that some number? Well, that some number is likely going to be 1. And so it would likely to be copper 1 oxide. Thanks very much.